Welcome to Roboschaf once again. I promised you a detailed video about Segway. Specifically, the way to set it up correctly, the way to program it correctly, what to pay attention to. You know, the basic operation app programming from early YouTube videos. For me, it's now really about, apart from the user manual and with all the know-how we have gathered over 1.5 years, to also show you what you actually need to pay attention to depending on satellite reception, to ensure that the thing works properly. But first, give me a minute. I really want to thank you for the tremendous attention to my last YouTube video, the summary for 2023. And naturally, my attentive listeners consistently provide me with valuable comments and feedback. And it is important for me to mention one thing as well. Dear Annette, I want to express my gratitude for your comment. One more thing is important at this point. Roboschaf is a manufacturer, an independent robotics specialist. And Roboschaf, like any reputable specialist retailer, can only make money if we actually use devices that work for customers over the years and do not cause any problems. Our testing center ensures precisely that. And it is an undeniable fact that we do not receive any monetary compensation in exchange for the videos we create. And I am able to say at this point, there has not been a single cent received from any manufacturer and not a single machine has been provided, but dear Annette, all of them have been purchased. And at this particular point in time now, because I am aware of how crucial it is, also the need for subscriptions. Due to your subscription, without the bell, as I mentioned, it is precisely the currency I require. To then also present dear friends with a critical note. These trainings usually take place internally within groups, and that is still relatively simple. Nevertheless, I apologize in advance. It will be a bit lengthy, but it is important to present it in such detail because those who truly want it to go smoothly on your property will need this know-how beyond the instructional guide. So, in terms of the content of the video, we will take a brief look at how the system is properly installed, what are the exact positions of the antenna, and what is the fundamental procedure for its proper setup. Then you must grasp one fundamental point, and that is the so-called odometry concept. The robot now lights up solid blue at the top, continuously blue. This indicates that the RTK reception is perfect, the antenna signals are strong, and the RTK system is working in this position. He is aware of his position, precisely where he stands, thanks to real-time kinematic GPS technology. At the property, you'll see the first part of the installation. Please examine it in detail nonetheless. It'll work relatively well. Here we can drive very precisely. The second part will be absolutely exciting, and that's exactly what awaits you. Why? If this RTK reception is lost, and it will be lost, then this robot will orient itself using odometry to determine its position and navigate accordingly. This implies that it performs calculations in both the forward and backward directions using an odometer, takes into account all rotations through the inclination sensors, and then the algorithm of the robot attempts to determine where it could potentially be located based on the gathered data and sensor readings. This is also the reason for this odometry package that we are presently working on developing. However, the devil is in the details. We will naturally eliminate that for the programming at this particular moment, because you have the Segway in front of you right now. And now, one thing is crucial. The instant a wheel loses traction at this point, which can occur easily because of the machine's center of gravity, the accuracy of this odometry is compromised. You can imagine it like this. The robot should drive straight. Currently, it only has a slight slip. And regrettably, at a distance of 10 meters, it is 2 meters away, where it certainly ends up being positioned sideways on the edge of the lawn with the mower. These are exactly the reasons why what is coming next is so important. I wish you all a lot of fun if you like what we are doing. Kindly subscribe, as it greatly supports us, and take pleasure in watching the informative video that follows. The most important thing, as with all RTK systems, is the RTK antenna. The RTK antenna, I have now mounted it all the way up here. And you can already see the cable route where the cable goes down taut all the way to the charging station. The charging station is located over there in the back. So, and for both, having a clear view of the sky is absolutely crucial. That implies that both systems at this point in time require a comprehensive view of the sky. We must look from there up into the sky, and you can already see, when we take a closer look up there in the assembly, it looks like we are at the gable height, so that even the gable of the house does not obstruct the view upwards, namely in the horizontal. You remember the explanation, the more we see from the sky, the better. And the second systematic is now also the charging station itself. And this charging station itself, which has now been set up, first of all here, appears to be a very, very good point in itself. You see, there it was standing. And then I relocated the charging station to a different location around the corner. So then it was both this position and that position. Here you can observe that it is a bit yellow, which is absolutely insufficient for our needs. Why? I'll aim the camera there for you. Let's quickly check the sky from this position and take a brief look. Here we can see through the grass, when they are wet in the morning, everything completely shaded. That means that definitely does not fit. And if we now stand here in this position and look at the sky there, then you can see the same thing again. There is the tree, the house is in front, there is another house in front, the whirlpool. Here we have the issue that we also do not have the sky view here. And each and every RTK system necessitates a sky view. It necessitates a sky view in all directions. And this is of utmost importance for the two reference points. Once for the RTK position up there, and once for the charging station. Now, a bit complicating this is that we can only use a maximum of a 20-meter connection cable between up there and the charging station. Certainly, this is considerably superior in the Husqvarna system, because in the Husqvarna system, we possess total autonomy between the antenna and the device. In the Segway system, there is a 20-meter connection. And now, I have just come from up there through the cable you see here, down to this charging position. So that is it for the programming part. Now let us move on to the Segway app. The Segway app is sensational. The mower has just connected, and now we're saying on the Segway app, you're coming together with the mower. It's about programming now. You see on the main page we have a mowing schedule. The cutting height is super adjustable, rain sensor and so on, so self-explanatory instructions. We go to the card management. There is no card present. Therefore, either navigate to the main page or select the option to create a new card. As I said, the setup now is very important. And now, please watch the videos on how you want to program it. And at this moment, the mower is examining precisely those points that we previously discussed. MEA is operating in a completely normal manner. The battery of the MEA is currently charged to a level that exceeds 50%. The MEA must now be in the charging station, which is very important, and GPS is currently active. So, when we program, we always deviate a bit from the MEA because we are, of course, a satellite shadow ourselves. We've understood that now. At the moment, a ruler is affixed to the rear of the mower for the purpose of measuring while in use. This 15-centimeter distance, usually attached to the arrow at the back, is intended to ensure the required edge distance for proper positioning is maintained. Of course, we're not doing it like this now, but by feel. But you can see that the edge mowing here is on the side, the mower is on the side, due to the manufacturer in SEC. This means that edge trimming will not be possible with a wireless system as we imagine it. Due to our inadequate satellite reception in that area, we require these 15 centimeters. Segway naturally assumes now to always produce the 15 centimeters, because this know-how that I am imparting to you here, no one else has it at this point. So, we mentioned the ruler is connected. Currently, various safety warnings are emerging, indicating that we should not have any children or similar in the application at this location. So that implies everything is prepared, and now we are relocating away from the ocean. And there is a cut. If we proceed to rotate the phone horizontally, we need to calibrate it. Please make sure to maintain a distance of a few meters now, as failing to do so will result in blocking the satellite signal yourselves. And in the event that we currently set it to calibrate, the robot will drive us out of the charging station. And at this time, this is the crucial point: calibration has been successfully completed. The categorization is starting now, and this is the point that has to be 100% accurate. And now you observe something of great significance. It is emitting a solid blue glow at the top. This solid blue color, when it is glowing, emitting a bright blue light, indicates that we have an excellent satellite signal reception, specifically in relation to the reception of the robot and the RTK position. We can initiate the programming process. Additionally, on the application, we can commence the mapping procedure. Now please watch the videos very carefully on the app. We have comprehended the instructions clearly, and here we go. Now we are moving the mower gently backwards with the application, forwards with the application. And if you drive a little now, you will receive a message indicating that you have not yet mapped. You have not initiated the mapping process yet. We have comprehended that naturally. And now we will operate the mower to its initial programming start position. And in this particular case, let's just start right here. Let's stand up at this very moment in time. We have a solid blue. This implies that we have the capability to undercut the 15 centimeter measurement from my point of view and maneuver with great precision. We've reached this starting point, and now it's all about the feeling when programming. As mentioned, we have bright blue. We state that the starting point has been reached, initiate calibration, and now we proceed to drive the mower very precisely forward, moving slowly. And you can already observe that it can be steered with great precision, at a very slow pace, thereby ensuring the distances from the edges. I will now stay a bit further away from the hedge during the programming phase to ensure accuracy in my steps. Please always ensure that you maintain a certain distance from the sea while driving yourself, as otherwise it can interfere with the signal that is being transmitted by the satellites, leading to potential disruptions in the reception of satellite signals. You see, one can drive unbelievably precisely. We program very slowly, please, all right? Take your time and be cautious. Why? When we drive at a higher speed with the robot, we have a negative impact on all the acceleration sensors, which adversely affects their performance. And the most important thing that the Segway can do is its odometry. You know what odometry is. The acceleration sensors compute the position by analyzing movements when the wheels are not slipping or experiencing any kind of slippage. And in locations with inadequate satellite reception, that is where the mower is capable of functioning. I am programming consciously at the moment because we are going to establish a transition at this point. So, and as you can observe, even with this flower bed, I am able to maneuver with great precision in this area. You currently have a clear view of the top side of the robot, where the blue light is consistently emitting a radiant glow. That implies RTK GPS is completely operational for me in this location while I am programming. So here you can beautifully follow the curves, as you can see. As I mentioned, it is very close to the edge. I'm marking here because we are programming a surface separation between top and bottom right now. And at a quick look, you always observe that the blue light is still continuously shining. Take a quick glance at the sky. We are already quite close to the trees and still have solid blue satellite reception, which means we can confidently continue programming the edges here. Moreover, by driving slowly and avoiding skidding, you can see that I am now significantly below the 15 centimeter distance because I know that the mower here, thanks to the solid blue, the continuous blue light, is impressively well on the move with the satellite signal. This reliable reception allows us to maintain a strong connection and continue our programming tasks without any interruptions. The mower's efficiency in receiving the satellite signal is simply remarkable. Now I would like to demonstrate something that is simply very elegant and extremely easy. I have drifted off a bit in this area. Then there is simply the eraser, and when you press on the eraser, the robot drives the track back so far until it is practically unrecognizable from its original position. Has reached the point again of how you want to proceed. Now you simply take out the eraser and slowly drive exactly this new direction. I intentionally maintain a separation of 15 units from the rocks in this area, but subsequently approach them on the slabs. Therefore, if we currently possess a blue luminous disc, we have the ability to drive remarkably near and exquisitely to the edge of the track. The wheels are slipping a bit now, you can see it. However, it doesn't lose the accuracy of the map for me. Why? There is no blinking. Therefore, everything is fine and there is no cause for concern. And if you nearly recall my previous videos, we are currently moving towards a position. Let's get a little closer to the sea. Look, now it's getting narrow. The tree in the middle, the house is falling apart, and so on. If we program in here at this moment, we will ultimately observe that the satellite signal is no longer adequate. And now I am driving up here very smoothly. I am driving as straight as possible without triggering the right lever, and you can already see the track. Check it out on the app. It is becoming increasingly inaccurate. It is shaking. Why? We no longer have a proper satellite signal available to us. You can see he doesn't draw such beautiful straight lines anywhere as he did at first, but it still shines consistently. So now we are just going to make a few more movements. We are now driving down the gradier here again. As I mentioned, I only steered very briefly one time, and now I am steering very gently around the curve while programming in this location. Why? In order to provide the odometry with enough time to calculate along the trajectory. And now arrives the challenging part. You will shortly observe that we are receiving a flashing signal. Here's a straight line. We have another. Look at this. Why is it so perfectly straight? Clearly there is a great sky view in that direction and also enough sky in that direction. Today, while programming, I have relatively few sheets. During priority programming, I have already received a flashing disc. We persist in our search. At present, I am ensuring that I maintain a considerable distance from the target. Because I know, you see the dirt, you see it on the app, how jagged it becomes. That means the satellite reception is not working properly anymore, and now we have it. Now you see it's blinking. We're blinking up there, which means the reception is no longer sufficient in that area, and now it's calculating purely with odometry, with the acceleration sensors and the wheels. And that means here we actually need to, and we also need to explain this to the customer, maintain a larger margin of error. You observe it's currently blinking green. Anything that blinks is unfavorable in this case. Notwithstanding this, you still observe a wholly uncurved line on the application. For what reason? Because he no longer records using satellites, RTK GPS, but solely through odometry. And if I now go very slowly straight, with as few movements as possible, when we have a curve, of course we have a curve, driving forward, then we have a straight line here. And it's important that we didn't slip before, because now he doesn't know where he is via RTK. At present, he possesses only a greater understanding of his odometry calculation compared to before. And you will witness, at this moment, we are currently entering the region where we unexpectedly regain real-time kinematic, RTK signal. And once we regain the RTK signal, we will be able to proceed without any obstacles. And there it is now, just like it was with programming. We are now out of the shadows again. The shadows of the house have disappeared. RTK is back online, and from now on, when you track it on the app, he has just made a turn. Observe that? Beyond the ocean. And we observe that was remarkably precise at this moment. He calculated the straight line purely forward using odometry, and here he has satellite signal again. And we can already say now, we have succeeded very well. Had we had slips in between, steps, too many curves, it would result in a much larger offset here upon regaining the RTK signal. So here you can see the Hong Kong really nicely in this spot. Very well done. We have calculated this beforehand, and you can already see from the track's unrest that we are now taking this corner very sharply, which we can absolutely afford here. We have an excellent satellite signal, and as you can see, the track is no longer straight at this moment because it is recorded using real-time kinematic GPS instead of odometry. However, as you can already observe, in spite of that, the quality of the track is still very good because we have a very strong satellite reception. So, we're now driving into this corner where I used to have the charging station. This is absolutely no problem now in connection with the odometry. Well recorded, we can skillfully navigate these corners at a slow pace, as previously mentioned, with some practice even from the front end of the vehicle. We have now completed our work on the current round of words. It's shining blue at the top. We have a good reception, so we can drive closer than 15 meters. From my point of view, there's absolutely no problem here. Please bear in mind at this moment, we consistently ensure that we maintain an adequate distance from the robot at all times. If he stops for a moment, no problem. He simply keeps his finger still on it. Here he goes around the movement again. When we have hedges are always a problem for RTK, especially when they are wet. A greater distance is preferable, and at present we are in the process of driving the final few meters towards the charging station. And now we drive straight through the charging station with the robot. Just lift it up, put the plate over it, steer forward out, and now we reach our closed point here. The process is simple and efficient, allowing us to seamlessly continue our operations. And he already says ready on the application. We tap on ready. One could continue programming here. However, we will do it a bit differently. We advise proceeding, and you are now able to program the next area. You are already able to observe the exquisite programming of the area. We performed admirably. The appearance is quite satisfactory. Our recommendation is to preserve the map. And now the robot or the application saves the map on the robot. That was the signal for it. We would like to continue. It has been saved successfully. Verify the signal strength. And now you can already see on the app, he has now drawn a transport route for the charging station, and there is now a test being conducted. You are required to complete this test, and the robot will execute it immediately. Locate the initial position. He possesses an outstanding RTK signal at this location. You observe he positions himself in a beautiful manner on it, and now drives with great skill and precision exactly along this prearranged track. What do we see on the app? On the app we currently observe in green. We possess an excellent signal quality here, and you can already perceive, as we track the robot from behind, we have a lovely color there. We'll now verify this fully. The entirety of the situation is now, as you can imagine, completely devoid of any spectacle in this entire area of the property, where we have a solid blue color indicating a continuous GPS signal and also green color present at this location. So at this point, we can already observe that it is relatively unproblematic, because our luck is, even if the satellite reception position does not quite fit here, you can perceive how it wobbles. There is simply a scarcity of satellite reception. But we are not at the edge here. There is enough room. He doesn't have a problem here. But you can already see how the accuracy guides here between the houses. And you can also witness it instantaneously when it enters an area where it demonstrates higher accuracy once again. It drives with an impressive level of accuracy right away without any delay. And now it gets really exciting. This particular stretch right here, which happens to be exactly in the shadow of the sun, as you can see, is currently equipped with a poor signal that is causing connectivity issues. The robot is blinking. It is clear that the robot is experiencing issues that need to be addressed and resolved. He doesn't know where he is anymore. So he has now rediscovered it once more, and starting from this point, he is actively utilizing odometry to assist himself. And commencing from this point, as you will witness shortly, the RTK service will be available once again for utilization. The duration it takes varies each time. The blinking still persists and shows no signs of stopping. He is still using odometry for driving, relying on the data it provides to navigate and make decisions on the road. You see, he is now too far inside because he couldn't calculate it accurately due to the slipping wheels. The situation there is too far inside. As previously stated, real-time kinematic GPS is not available in that area. Solid blue, and as you can see, usually RTK comes significantly further ahead here. So in this position, approximately now we have it back again, and as soon as we have it back, it's completely accurate again. That signifies the art within programming is in fact precisely what I have shown you, without any deviation or alteration in its essence. Where there is poor satellite reception, the app indicates while driving whether the dirt is smooth or rough, or of course via its blue light. We must maintain our distance there. Now let's have a very elegant look at the packing process. You already see a beautiful real-time kinematic, absolutely no problem at this point. And at this moment we are driving in. And he is currently reaching the charging station, so he is almost finished with a progress of 98%. Testing has been completed and the map is now ready. And now he informs me on the application to return to the charging station. That means he will now park the vehicle into the charging station, and you will see how nicely we have programmed this first area while he parks his vehicle at the charging station.